Compared to the other rocks in the shop, this rock looks pretty ordinary. But this rock represents a landmark in our understanding of time.
It comes from outer space. My rock is a fragment from a giant meteor that left this. The Behringer meteor crater in Arizona. "300,000 tons of rock from space collided with Earth and blew the ground apart." My fragment is part of that meteor. It's debris from the very birth of our solar system.
When the solar system first formed, it was full of rock and debris, out of which the planets and the Earth condensed. However, there were some bits and pieces of rock that did not condense.
And those leftover rocks remain, primitive relics from the birth of the planets.
That's the origin of the meteorites. They share a common age and common origin with the Earth. So if you know the date of this rock, then you know the age of the Earth.
In 1955, using radioactive dating on this very meteor, scientists at last revealed the Earth's true age. All ways to date the Earth have agreed. The Earth is 4,600 million years old. That's 4.6 billion years. Earth time is unimaginably vast.
It's amazing that in just a few centuries, our view of the depth of Earth time has changed so radically, and has completely changed our conception of who we are. How are we to comprehend this vast ocean of time?
And if we begin to understand the immensity of Earth time, what does that mean for our sense of our place within it?
Let's say that 1 millimeter represents 1 year backwards in time. Here we are in the present. This is me in the 21st century. And if I go back 5.8 centimeters, then we reach 1947. That's the year I was born. Now let's talk about the Roman conquest of England. That took place in the year 43 AD. For that, we had to go back about 195 centimeters to about here.
Even the length of my table represents 2,000 years. But I want to measure out the whole of Earth time, and 4.6 billion years is going to take me a whole lot further. On this scale, every mile is an epoch of nearly 2 million years. As the sheer depths of Earth time roll on, a human lifespan seems so insignificant. I've traveled 2,500 miles, 4.6 billion years of time, the entire age of the Earth. It's taken me across the whole of America, and it's made me feel, by comparison, very, very small indeed.
Compared to my own 58 years, that's how vast Earth time really is. My own lifespan is nothing but a pimple on the face of Earth time. That's what makes 4.6 billion years so captivating, but also so unnerving. Our Earth is constantly changing, but it happens so slowly that we're simply not around long enough to witness it. There are, however, some places where occasionally we're able to glimpse these changes in action. Kalapana, 1990. This Hawaiian fishing village faced total devastation from the most active volcano in the world. Kilauea. Hot lava buried house after house. Kalapana has gone forever. It lies 50 feet under a blanket of solid rock. This was once the road to Kalapana. For us, such violent events are catastrophic. But for our Earth, they are no more than the beats of a much greater timescale of change. To understand this, I'm going to take a closer look at the engine that drives this change. Kilauea, the world's most active volcano, has been erupting continuously since 1983.
This is truly a fantastic experience to be literally face to face with a live volcano. Forces here. The power of volcanoes is basically the power of the Earth itself.
But this power isn't only a source of destruction. It's the creator of new land. This is one of the youngest parts of our planet, built from countless layers of solidified lava.
Imagine that each of the Hawaiian Islands was created in this fashion. Volcanoes punching their way through the crust of the Earth, forming islands. Island after island after island. This is the origin of the Hawaiian chain, and it's still happening right before our eyes.
Over time, this process causes change on a huge scale.
This island was created by volcanoes.